Hello, everyone. My name is Kwame Ade. I'm the founder and director of the Center for Operations Research and Data Science, CORDS. I also double as an assistant professor of business analytics at the Minnesota State University, Moorhead. The goal of today's video is first to identify the optimal portfolio for two selected stocks using the R optimization infrastructure. And then we want to also be able to compute Sharpe ratios along with plot for these two stocks. And then finally, we'll plot the efficiency frontier for these two stocks. Now, the stock of interest are Tesla and NVIDIA. As all of you may be aware, Tesla and NVIDIA had been performing well for some time now until recent times when it began to decline. So I'll just show you here. And you see, this is for Tesla stocks. It had been rising recently from, you see, this is from December. You saw it peaked around the 9th of December. And then it began to decline. And then since January, we have seen this sharp decline until today. And this is where we are. If you look at NVIDIA had a more upward trend, and then it trended upward until a peak of about, let's say, November, and then it began to decline. So with this being the interest, the question we ask ourselves is, as a portfolio manager, what is the optimal combination of these two stocks that will help you maximize returns and then minimize risk? So if you see here, I'm going to use the Harry Markowitz mean variance portfolio optimization to be able to do that. And the packages I'm using are Quant Mode, Performance Analytics, Portfolio Analytics, the R optimization infrastructure, and then I'll bring in a plugin for quadratic programming, that is if I need it, and then a plugin for the linear programming kit, that is the GNU linear programming kit. So these are the libraries. Because I have installed mine already, I don't need to install it. But since you may not have installed yours, you may want to install these packages. So then I move straight to using the quant mode to extract the data from Yahoo Finance. So here I say it should call the tickers Tesla. This is the code for Tesla, and this is the code for NVIDIA. And I'm taking 3 years worth of data. Now, 3 years worth of data, I'm saying it should start from today and go 3 years back. So I run this by calling in the library. And then you see over here, I have my NVIDIA stocks here, and then Tesla stocks showing here. We are interested in using the adjusted prices, so closing prices. So we'll just focus on using the adjusted closing prices. Now, we need the returns. So I'll plot the returns because typically investors or portfolio managers are concerned about the returns. So I now have my returns data. Now, in the portfolio optimization concept, we typically need to understand our covariance metrics, know our standard deviation, and know our mean returns. So in line 35, I run and compute the column means. Now take note that over here, I'm using 252. Now I'm using 252 because there are 252 trading days in a year. So this data I took, which is 365, will have gaps in there, which will exclude weekends and then some holidays. Then again, I compute the covariance metrics, and then I take the standard deviation. I get the standard deviation of returns by taking the square root of the diagonal element of my covariance metric. So that's what I do here. So I run that, and then I have that also there. So now I can decide to look at the means for these two stocks. So let's look at the mean returns for these two stocks. And what you are seeing here is that over the past 3 years, the annualized mean returns for Tesla is 0.06. And then that of NVIDIA is 0.65. Then we can look at the standard deviations. So looking at the standard deviations, we see that the standard deviation for Tesla is 0.62, and then the standard deviation for NVIDIA is 0.55. So what that tells me is that this is my expectation if I decided to purchase only Tesla stocks. This is my expected returns, and this is the expected risk, because bear in mind, standard deviation is the basic form of risk or basic measurement of risk. However, if I had decided to stick with NVIDIA, this would have been my expectation, and this would have been my risk. So then I move on and ask myself, because I want a combination of the two, I need to find out what is the correlation between the two. So in line 45 and 46, what I'm doing is I compute I print out the correlation, and this is the correlation. So I see here that there's a positive correlation between Tesla stocks and NVIDIA stocks. However, this correlation is less than 0.5. So the correlation is 0.43. So both typically would move in the same direction, right? That means if Tesla stock is going up, NVIDIA stock will also be going up. If Tesla stock is coming down, NVIDIA stock will be also be coming up. But then the strength is just 0.43. Yeah. So now that I'm done with the statistics or descriptive statistics, I want to now set up my constraint. So this is how I set up my constraint. So this first constraint specifies for my assets. And then when I come to line 65, so sorry, 64 is where I set my objective function. Then in line 65, I bring in my first constraint. So this first constraint tells me that the summation of the portfolio must be 1. That means I'm going to be fully invested. Then the next constraint is also telling me in line 66 that I'm taking a long position. So by long position, that means I have purchased the stocks with the expectation that their value is going to increase over time. Then I do add this constraint that I am using the mean returns, and then this constraint also says I'm using the standard deviation as my risk. So let me run my setup or my optimization setup. So I do have that one here. So now that I have my optimization setup, I want to create the efficient frontier. So to create the efficient frontier, I specify here that the portfolio should be set up based on the constraints I have above here. And then I specify here that it should specifically use the mean variance portfolio optimization. So R allows you to specify it as mean hyphen standard deviation. And I'm saying it should do that using 50 portfolios. Then over here, I'm specifying that the risk-free rate should be 5%. You know, in recent times, you have been in a high interest rate environment. So I decided to use this as 5%. So I now go ahead and I run this efficient frontier. So I have that uh, done now. Then, now that I have the efficient frontier, I can go ahead and find the minimum variance portfolio. So by using line 80, I am able to create the minimum variance portfolio. So this line helps me to create the minimum variance portfolio. So that I run also here. Then for me to be able to get the tangency portfolio, I need to be able to have all the Sharpe ratios. So in line 84, I compute the Sharpe ratios. And the formula for the Sharpe ratios is the expectation of your returns minus the risk-free rate divided by the standard deviation of your investment returns. So that is what I do here. So expectation minus your risk-free rate divided by the standard deviation. So that is line 84. So I run that too. So now that I have that Sharpe ratio, I can definitely get the tangency portfolio, which is my maximum Sharpe ratio, by using the which function to see which of the Sharpe ratios I computed is the maximum. So I run that. So now I can go ahead and plot my efficient frontier. So for me to plot my efficient frontier, I have my x-axis to be the risk component, which is the standard deviation, and then my y-axis is the return component, which is the mean returns. So I'm using just the plot function. So I have them showing here: standard deviation, x-axis, expected returns, y-axis. Then the rest of the details here are just aesthetics, where I bring in the title or of the plot, and then I have the size of the labels or the plots, and then I also have the size of the axis, and so on and so forth. So because I want to run this, I'll just expand my plot space to be sure that I get it to run. So here we go. So if you see it here, this shows me my efficient frontier. So the efficient frontier shows me the combination of standard deviation and expected returns for the different portfolios. So this is the maximum Sharpe ratio that is shown in blue here, and this is the minimum variance portfolio. So this is the portfolio that gives me the least risk. And of course, if we believe that the higher the returns, the higher the risk, then we should also believe that the lower the risk, the lower the return. So we are seeing a very low returns associated with this low risk. So this is our efficient frontier showing here. So since it's difficult to know the specific values based off the graph, I'll try and print the values for the minimum variance portfolio. So I'll do that in line 105 and 106. So this is my minimum variance portfolio. So my minimum variance portfolio is telling me that my expectation is going to be 0.0016, and then my standard deviation is going to be 0.03. Then it's telling me that for me to be able to get that minimum variance portfolio, I must have 39% or 0.398 as the weight of my Tesla stock, and I must have 0.60 as the weight of my NVIDIA stock. I can also look at the maximum Sharpe ratio or the tangency portfolio. So if I print that one in line 108 and 109, then it is telling me that my maximum Sharpe ratio is has an expectation of 0.0025 with a standard deviation of 0.034. And then what it is telling me that for me to get the highest Sharpe ratio, I need to invest all my money into NVIDIA. Now, when we talk about the Sharpe ratio, it is a measure used to evaluate the risk adjustment or risk adjusted performance of your portfolio. So what that implies is that your maximum Sharpe ratio represents the optimal risk adjusted return portfolio on the efficient frontier. So this is the optimal risk adjusted portfolio. Now, your choice between the minimum variance portfolio and then the maximum Sharpe ratio is always going to be dependent on your risk aversion level or your risk appetite level. But however, it's good to know that this is it. Yeah, so why don't we look at the risk and returns for different weights? So here I'm trying to calculate the risk and the associated returns for different weights of my two stocks. So I set up the portfolio return, that is a summation of the weights and then a product, sorry, of the weights and then the returns. And then again, I come to the risk, and the risk is the weights times the covariance matrix times the weight all squared. And the first component is the transpose of the weight. Then, of course, I have my Sharpe ratio here. Then I compute my returns. So I say the weight should range between 0 and 1, and then there should be increment of 0.01. So I compute the rates, and then I use the apply function to show them. So now that I have that, I want to plot the risk return profile. So for me to plot the risk return profile, I'll show the codes before I move on. So these are the codes for me to plot. So the portfolio's risk and then the portfolio's returns. And then these are the labels I assign to them. And then I assign colors, and then I bring in the aesthetic component. So once you have seen the code as it is, I'll run the codes so that we can see the output here. So this should be the output. Good. So now, this is the risk and return profile for NVIDIA and Tesla. So what you are seeing here is the annualized risk if you are going all out on Tesla. and this is the associated returns. However, if you decide to go all out on your NVIDIA, which also happened to be your maximum Sharpe ratio or your tangency portfolio, this is going to be the annualized risk and then its annualized return. So this is your risk return profile. And then this is where we see our minimum variance portfolio. So this is the annualized risk associated with it. And then this is the annualized returns, sorry. And then this is the annualized risk. So this is how we stand. So I can decide to just print these out so that we see the actual numbers. So from line 150, and I can expand this for you to look at the codes. So from line 150 to 155, I look at the optimal allocations for my minimum variance portfolio. So I run that, and then we have the results here. So it is telling me that for my minimum variance portfolio, the optimal allocation for Tesla is 40%, and the optimal allocation for NVIDIA is 60%. And when I do that, my expected annual return is 41.59%, and my expected annual risk is 49.45%. Now, how does this compare to the tangency portfolio or my maximum Sharpe ratio? So let me run that and see. So if I decide to select the tangency portfolio instead and allocate my investments according to the maximum Sharpe ratio, of course, that means I will not allocate any amount of money to Tesla. I will use all my money to purchase NVIDIA stocks. Now, when I do that, my expected annual return is 65%, and my expected annual risk is 55.4%, and I have a Sharpe ratio of 1.0835, which is fairly good. Very, yeah, I'll even say it is a very good Sharpe ratio to have. And even if you want to compare the actual numbers, look at how much return increase you do get in comparison to risk. So what you are saying here is that on your maximum Sharpe ratio, you are getting higher increase in return compared to the increase in risk, because what I'm seeing here is close to 24 percent, and then the risk increase I'm seeing here is just about 6. So it looks like your tangency portfolio might be a good choice. But then again, your choice on this range of investment or looking at it here is dependent on your risk appetite. Thank you very much. See you next